Here's the first set of review that we're going to be looking at for trigonometry. We're looking at each one of these, kind of going through and reviewing a little bit for the test. This is not the way that your test is going to look, but some people wanted some extra problems on these, so here you go. I'm not going to waste your time by doing all of them. You can check the answer key if you have a question on which ones, if you missed one or you wanted to double check something. So convert each degree measure to exact radian measure. Well, exact is underlined because we don't want decimals. Okay, we don't want to round it. We want it to be exact. So that doesn't mean we're doing anything different, though. I want to turn it in from degrees, so I want to get rid of my degrees and turn it into radians. Okay, we're not doing anything different for that. It doesn't say to make it positive, so I can leave it as a negative. Nothing really truly happens with that. And so when I look at negative 415 times pi, that I don't want to take that times 3.14. I want to just leave it at times pi, and then I want to do that divided by 180. So really the thing that I'm doing is negative 415 divided by 180. And then if you're doing that on your calculator, you're going to end up with a decimal, and so you want to turn that into a fraction, and you can do that if you have a TI 83 or 84 by doing math and then enter. Okay, math enter will get you the fraction here. So I have negative 83 over 36 for the fraction part, and then the pi is still on top, and so this is the exact radian measure. Okay, it doesn't say it has to be positive, so just go ahead and leave it like that. Okay, let's run down on this one. Check out a positive one here. So I'm going to multiply this by pi over 180. So I have 100 pi over 180, and that 100 divided by 180, if I turn it back into a fraction or reduce it, is 5/9, and that pi is going on top. If you want to do one that you're going to be able to check, let's say on your unit circle, you can check this one, 270. So 270 divided by 180 gets us a 3 pi over 2. So you can check that one on your unit circle, make sure that that you're getting these correct. Second page of this is going the other way. So I'm going to convert the radians to degrees. So I'm doing the same exact thing, except I want to get rid of the radians. So I get rid of the pi, and so I need to have 180 over pi. So the pi's are going to cancel each other out right away. Okay, so then I have 29 times 180. And then I'm going to take that number and divide it by 36, which gives me, in this case, I get 145 degrees. Okay, so don't make these harder than they need to be. Same thing happens down here. Let's say we have, let's go number 26. I want to get rid of the pi, so the pi's are going to cancel. So I go negative 269 times 180 and take that and divide it by 60. That gives me negative 807 degrees. Please put the degree symbol on it to make sure that you have it right. If you're looking at one that you could probably check on the unit circle, I don't think there's any on here that you can check on that. But just make sure that you're multiplying by 180 over pi when you're going from radians to degrees. The third one, find the exact value for each trig function. This question ultimately, again, says exact value. So when you see exact value, that means that you're either going to leave it with pi's or you're going to leave it with some square roots. And so ultimately, on this one, we're going to leave it with some square roots because we're looking for exact values. These are going to come from the unit circle. And so we're going to have it left with a square root. So ultimately, we're going to be flipping back and forth here between this worksheet and your unit circle. We're looking at, let's do an easy one here, cosine of pi over 4. Well, you need to know what cosine is. Cosine is the x value, so when we go here to cosine of pi over 4 is right here. The cosine is the square root of 2 over 2. And so I get cosine of pi over 4 to just be the square root of 2 over 2. This is just picking things off of the unit circle. Okay. Ultimately, what we end up getting here is a situation where we have tangents. Okay, you need to remember that we tried to fill in some of those things for tangents. Cotangents are the reciprocals of the tangents, and so again, what we're looking for are things on the unit circle. So when I do, let's say one like number 13 here, I've got negative 23 pi over 6. Well, I can't necessarily find negative 23 pi over 6 just looking at the unit circle. But I can go, and I can turn this negative 23 pi over 6, I can turn it into a coterminal angle, 23 pi over 6. And the way that I do that is by adding 2 pi to it. And in order to turn it into a common denominator, I had to multiply both top and bottom by 6. So if I do that, I get a negative 11 pi over 6. And if you're not comfortable looking on the unit circle for negative 11 pi over 6, that's okay. Add 2 pi again. Okay. Negative 11 pi over 6 plus 12 pi over 6 gives me 1 pi over 6. Well, let's explore that a little bit on the unit circle here, just for the fun of it. So I get a pi over 6, so I'm going to end up here. This is my angle that I'm looking at. But that's the positive angle this way. So if I wanted to go the negative angle, the negative 11 pi over 6, if I go all the way over here, this is negative 6 pi over 6. Okay, and so I want to start getting used to or a better idea of where I am on this unit circle, even if I have negative angles or if I have angles that don't necessarily match up the way that I think they should exactly with the unit circle. So here's negative 6 over 6, negative 6 pi over 6. And then I go up here, I'm adding another pi over 2 to that, and so I'm actually taking, and I end up at a negative 9 pi over 6. This is going to be 10 pi over 6, and then I get to 11 pi over 6. Okay. That was a horrible straight line. When I look at this, I go a negative 11 pi over 6. That gets me to almost one full rotation, and I know that because a negative 12 pi over 6 would be one full rotation. Okay, so I'm 1 pi over 6 short from going a full rotation. There's lots of different ways that you can look at this. Ultimately, it's going to be your responsibility to find the one that works for you. Okay. If you're using coterminal angles, that's fine. That will ultimately work as well. Let's just take a look at one of the other ones that is not sine or cosine. Let's say cosecant. So I've got cosecant here in number 20 of 10 pi over 3. Well, again, 10 pi over 3 is not on the unit circle, but I do know that if I look at this and I reduce it, I have 9 pi over 3. Reduces to 3 pi. So I've gone around the circle one full time, that's 2 pi, and I've gone around the circle another half a time, and I'm past that point. I'm 1 pi over 3 past that. Okay, if that doesn't make sense, go ahead and do coterminal angles. I've got more than pi over 3, so I want to subtract 2 pi from this. So that gives me, when I get a common denominator, 6 pi over 3, which gives me 4 pi over 3. I can, if you wanted to, you could subtract another 6 pi. That gets you into negatives. I would think that that this is where you're probably going to stop. 4 pi over 3 when I come on the unit circle here, it gets me down here at 240 degrees in the third quadrant. But ultimately, when I look at this again, if I am looking at this in terms of maybe counting pi's over 3, I've gone 1 pi over 3, and then I've gone 2 pi's over 3, and then I've gone 3 pi's over 3, and 4 pi's over 3, and 5 pi's over 3, and 6 pi's over 3. I'm going a total of 10. So 7, 8, 9, 10. Okay, so it gets me to this 4 pi over 3. I went a little bit too far here. But it gets me to this 4 pi over 3 if I were looking at trying to count this as well. Okay, I'm just going around the circle a bunch of times. That's it. Okay, but I end up at 4 pi over 3. What was I looking for? Cosecant, I believe. So the cosecant is related to the sine, which is the y value, so I get negative square root of 3 over 2, which makes me believe that since I didn't do anything on the last one, we didn't actually write the answer, so we'll go back and do that one. Cosecant, I had negative square root of 3 over 2, so I've got negative 2 over the square root of 3 as the cosecant. I can't leave the square root of 3 in the denominator, so I need to multiply both top and bottom by that. So I get negative 2 square root of 3, and then the square root of 9 is a 3 on the bottom. So number 20 is 2 square roots of 3 over 3 for an answer. Now let's go back to 13. We ended up here at pi over 6, and we were looking at sine of pi over 6. So come back here. Sine of pi over 6 is right here at 1/2. So we just didn't finish the problem. We did the all the coterminal angles stuff, but we didn't actually answer the question. The exact value at pi over 6 of sine is 1/2. Okay, so go through. This is probably going to be a much tougher worksheet than the first two, so take some time on it. Right triangles. So we have special right triangles, and if you remember special right triangles from geometry, then please feel free to work through that. We will cover this special part again later at a later time in this class. But for right now, at minimum, when you're going through these problems, you need to kind of just be using the sines, cosines, and tangents. Feel free to use cosecants, secants, and cotangents, but I think the majority of us are good with the sine, cosine, and tangent part. So we've got the angle here in number 1. I'm looking for the opposite side first. And so I've got opposite and adjacent are given to me. So I'm going to do tangent of 45 is equal to the opposite, which is y, over the adjacent, which is 4. So I get y is equal to the tangent of 45 times 4. Well, there's a lot of different ways that I can do this. I could do the tangent of 45 just by going to my unit circle. That angle is on there. I could type it in my calculator. Ultimately, it doesn't necessarily matter. But if you think about you're going tangent of 45, and then you're doing that 4 times, then you actually end up with this just being 1 times 4, which is 4. Because the tangent of at 45 is square root of 2 over 2 divided by the square root of 2 over 2, which is 1. 1 times 4 is 4. And you want to start making a few connections on these, but we end up with y equal 4 for number 1. I still need to find x, so don't forget about finding x. X is the hypotenuse in this, so I've got an adjacent side and a hypotenuse. So I can do cosine of 45 is equal to the adjacent over the hypotenuse. A couple different ways to solve this one: cross multiplying, dividing. Multiply by x and then divide by cosine of 45. A lot of different ways, but ultimately you should end up with this calculator problem. And again, you could get that from the unit circle. The cosine of 45, if I'm looking on the unit circle, is a square root of 2 over 2. But I'm okay with you getting the decimal version of this. And let's round to 3 decimal places, so 5.657. And so the decimal's fine. It would be really awesome if you gave me this as 4 divided by 2 square root of 2 over 2 and did something like this. And then gave me the answer as 4 square root of 2, because if you took 4 times the square root of 2, you're going to get that same exact answer, 5.657. But you don't have to do that. It's not necessary, but it would be really, really cool if you did. So go through and do those special triangles. This sheet's the same as the same special triangles. Solving trig functions without a calculator, so you should not be using a calculator. Okay, I'm looking on my unit circle then. So the sine of theta is equal to 0. So I want to know when the sine is equal to 0. and this might be a little advanced from what we've been doing, but I felt like it fit in with 1.2 a little bit. And if we're going through and we're finding that maybe it's a little bit too advanced for us, we'll take a step back and we'll spend a little bit more time on this. But I forgot what the question was. Sine of theta is equal to 0. So I'm looking where sine is equal to 0. Well, places that sine is equal to 0 is where y is equal to 0. There's one here and there's one here. So there's two different answers. Okay, and so I end up with 0 and 180. Remember that my answer had to be between 0 and 360. So I get 0 degrees and 180 degrees. And we're not using the radians, but we could say 0 radians and pi radians, but that's not what they're asking us for. Okay, so if you're going through and you're doing a problem, let's say like, I don't know, number 19. Number 19, we have to solve this theta for its to itself. So I end up adding 3 to both sides. So I want to have the cosecant of theta divided by 3 is equal to 2. So I'm going to take and get an answer of cosecant equal to 2. We could take this outside of the unit circle, but you can find this answer inside the unit circle as well. All right, so take some time, go through this sheet. This might be one of those that we take out though if we have some trouble with it and spend a little bit more time on it when it comes back to us.